Okay, good morning. Hope everyone is staying safe here. Okay, so we're closing in on the last month or so of the semester, and I think what day was it? On Friday, I posted your grades for the midterm. So you should see your midterm two grades posted. All right, so you probably already saw those. The grades were fairly high, and everyone, it seems like, did pretty well on midterm two. So you guys did a good job of understanding the material there. So yeah, it seemed like the scores were very high on midterm two. If you did miss any points, you can look at the solutions I posted in the midterm two section. All right, so I posted the solutions there if you saw those. All right, so we're gonna do another exercise, and we're finishing up chapter 14 this week. All right, so here's what we're gonna do today. We're gonna do example 14.7 and 14.8. And then we've got a few more exercises. This one for today, and then we have a different assignment for Thursday. And so note that next week is Thanksgiving week. So I think I have. Yeah, so I think I just did kind of like a fill in, but we will have our meeting on Tuesday next week. But obviously, or when is that? When is Thanksgiving? The 26th? Yeah, 26th. Okay, so next week I believe, yeah, November 24th. So we will have a meeting on Tuesday next week before Thanksgiving, but obviously Thursday. We're not going to have a meeting on Thanksgiving Day. So just ignore that for week 13. All right. So everything else is normal except that there's obviously no meeting on Thanksgiving Day. Okay. Let's start. Example 14.7 and 14.8, and you can go to the Blackboard spot. Okay, so you can open up example 14.7 and 14.8. And then the first one we'll need is the pharmaceutical sales. You can open that up. Okay, so we're gonna learn about a couple new different exponential smoothing methods briefly. And so let me read the description for this one if I can find it. All right, so this is the one we're doing, and this is your in the textbook version that we're using. This is example 14.7. So forecasting quarterly sales at a pharmaceutical company. Pharmaceutical sales, which we have, contains quarterly sales data for a large pharmaceutical company for the first quarter of 1998 through the fourth quarter of 2007 in millions of dollars. The time series plot in figure, we'll make our own plot, but it's down here, indicates a fairly consistent upward trend with a relatively small amount of noise. And so Kinholt's method, which I'll explain why we're using that and what the method is, be used to provide a reasonably accurate forecast of this series. So this is a different type of exponential smoothing in which you might want to use if your data exhibits a trend. And you can see here that this plot shows a clear upward trend. And if you have an upward trend or a downward trend or some kind of trend, then your forecast wants to incorporate that trend. So we would probably expect, it's hard to know exactly what the next quarter sales are, but you can pretty much guess that over time, it seems like these sales are trending upward, okay? So if there's a trend, this method of exponential smoothing can incorporate that trend. So you'd want to use Holt's method if you plot the data and see a trend, which is probably what we're going to see when we do this data analysis. Okay, well, let's look at the data. We'll start the exercise, and then we're going to plot the data, and we're going to see a trend, which is going to indicate that we're going to want to use this Holt method. Okay, so let's go to the Word document. That's not the Word document. Okay, so we're going to learn about these two methods today. Holt method in example 14.7. And Winters is exponential smoothing, which is for seasonal, which I'll explain in example 14.8. But there's a couple videos, like 10 minutes or so, that if you want to get some more information on these two types of exponential smoothing, I'd recommend these videos to look at. Yeah, so let's go ahead and start example 14.7, the one we just described. All right, so we're going to try to forecast quarterly sales at a pharmaceutical company, and we'll look at the pharmaceutical sales spreadsheet. Let's first, step one is we want to see what our data looks like. Let's, step one, create a time plot of pharmaceutical sales over time. All right, so all you want to do here is select all of the data with the associated quarter. So you can select A1 to B49. All right, so select all of that, even though you're selecting some of these blank spaces. And the reason is because we're going to put the forecast on there when we're done with the analysis. So select all this A1 to B49, and let's make a plot of that. Okay. Insert. Let's try recommended charts. None of these. All right, so just go to all charts, and you want to do the one, just the basic line. So the line chart like this. Choose that and hit OK. Okay, so we got this. This is our line chart, and it shows every quarter. And so you can just make a couple labels to show what the axes are. Okay, so we got sales over time in the quarter. And let's go ahead and click on this. And you can hit the plus sign or go to chart elements. And you can take away the chart title and you can add axes titles. Okay, and this one is, let's just call this US dollars because we're going to have the sales and we're going to have the forecast. All right, and let's call this the quarter, or what this is the quarter. All right, so what we see is this is the sales in US dollars. This is the respective quarter we observed it, and what you can see is a clear upward trend, and we're going to incorporate that upward trend, or try to, in our forecast. Okay, so we got the chart here. Okay, so what I'm trying to illustrate in this example is we have, here's the quarter, here's the sales, and I'm going to show you that using just a regular exponential smoothing method, you can do that, but when we compare the errors or how well it captures the data, Holt's method does a better job, and we're going to end up using that one. Okay, so let's go to step 2. Okay, so we've got the time plot, and we can see an upward trend. Let's first start with the one we learned last week, which is just simple exponential smoothing. So let's use alpha equals 0.9 to generate an exponential smoothing process, including the forecast for the next quarter. All right, so let's just do this using data analysis again. Okay, so I set up a little spot to put that. All right, so we're going to use data analysis. So let's make sure that everybody has this. All right, so does anyone not have data analysis? We've used this a few times, but I just want to make sure that when you click on the data tab, does anyone not see the data analysis here up in the spot? So data tab, and double check that you have data analysis, which we've used a few times, but if you don't have it, let me know and I'll help you activate it. All right, so we all have it, and let's go ahead and use it. Okay, all right, so data, and then data analysis. And let's choose the exponential smoothing option right there. All right, hit OK. Okay, so the input range is all of the sales. So you can choose, hit this button. So input range is B1 to B41. Hit the button again. So we want to use an alpha of 0.9, which means the damping factor is defined as 1 minus alpha. So our damping factor is going to be 0.1 because that gives us an alpha of 0.9. So damping factor is 0.1. Click on the labels box, and the output range, click on this button, and you want to choose where I put it the alpha equals 0.9 spot. So C2, sorry, to C2 to C42. Okay, so look at your exponential smoothing parameters, and this is what you want to have. Input range is B1 to B41. Damping factor is 0.1. Labels are checked, and output range is C2 to C42. Right? Okay, you can hit OK. All right, so we've got some formatting to do, but did everybody get the exponential smoothing process here in the C column? Everybody good so far? All right, first, let's format the C column to look like with this currency. So you can click on the C like that, so it selects the whole C column, and let's just do Home tab, Format Cells, Currency, 2 decimals with the dollar sign. All right, so we're just formatting currency, 2 decimals, dollar sign. Okay. And then let's scroll down. And you can see it's done the exponential smoothing process like we liked. And we want to get the next month's forecast. And to do that, go down to cell C41 and just grab the bottom right corner and drag it down one like that. And so this formula in C42 should be equals 0.9. That's our alpha times B41. That's our last sales. And then 0.1, that's 1 minus alpha times the last forecast. All right, so double check that your value in C42 is this, 8,234 and 5 cents. That's what you should have there. Okay, and we did that. All right, now let's calculate the APE with our same formula. All right, getting the absolute value of the change over the original. And we'll copy the formula down, and we'll get the MAPE, and then we're going to compare them, the regular method which we're using, and learn to the Holtz method with the trend and see which one captures the data better. All right, so starting in D3, Let's calculate the absolute percentage error, which is equals, here's the formula, equals. Okay, this should look somewhat familiar, equals ABS, double parenthesis, B3 minus C3 divided by B3. So it's the absolute value of the actual minus the prediction divided by the actual. So ABS B3 minus C3 divided by B3. All right, that's already in percentages. That's nice. Okay, then you can grab the bottom right corner of D3 and drag it down to get the rest of the APs like this. Okay, drag it down to D41. And then right here where it says MAPE, that's where we're going to calculate the MAPE for the blue alpha equals 0.9 exponential smoothing forecast. So in D51 equals average of D3 to D41. So the average of all the APE calculations you just made. All right, and you should get here in cell D51. I got 4.62%. So that's our mean absolute percentage error for the alpha equals 0.9 process. Do we get that? 4.62%? Okay. All right, so, oops. All right, so I put the Holtz method forecast here. So the Holtz method is something I want you to learn, but we're not going to, without like an add-in feature, you can't do some of these advanced methods in regular Excel. So I did it in a separate program, and I just put the forecast here. So all right, so we can't generate a Holtz method forecast in Excel without an add-in package, and obviously I'm not going to have you guys buy an add-in package, but I did want you to learn this method because it's in the textbook and it's useful. So you can, I'm going to show you what the forecast got, but just I got these forecasts using a different software program. Called RStudio, and this is a more advanced statistical software package, or just it's a more advanced processing system, whatever you want to call it. And so if you do any advanced statistics or anything like that, you might come across RStudio. It's free, but it's kind of beyond the scope of this class. And if you did want to learn about how to do these kinds of methods, I've in the past taught classes using RStudio. So if you're interested in these more advanced forecasting methods, I'd be happy to help you with those. But for this class, we're not going to use a different software package. But I just wanted you to see what this Holtz method does. So what I want you to know about Holtz method is It's a type of exponential smoothing, which you want to use or try to use if your data shows a trend, which it does here. Okay? And so from that other software package, I just did a Holtz method forecast. And this is the MAPE for the Holtz method. So next step here. All right, so what we're going to do here is just compare them. So which method has the lowest MAPE and what should be our forecast for the next 2 years? Okay, so this is, we got the MAPE here for the exponential smoothing, simple exponential smoothing. This is the MAPE for the Holtz method, and it's actually pretty close, but the Holtz method's a little bit better. 4.4% is lower than 4.6%. So given the two, we choose the Holtz method, and these are the Holtz method forecasts I got for the next 8 quarters using the other software program. So I put the values on here. So let's just show that these would be our forecasts for the next 2 years, given the lower mean absolute percentage error. So let's just put these onto the graph so we can see them, and you'll see that the forecasts incorporate the upward trend. And when you see the forecast, it'll make a lot of sense, or it'll look right. So the next step is we're choosing this one. Okay, and the final step for this one is let's add the Holtz method forecast to the data so we can see the data upward trend, and then we can see the forecast. So go back to the spreadsheet. Okay, what I want you to do is we're going to add the Holtz method forecast to the rest of this graph. So if you click on the graph, this might have to do this a few times, but if you click on the graph and you right click it, just the middle of it, you should see an option there for select data. And then down here, you should see where it says legend entries series, click on add. In the series name, all right, if you get here, click this button. The series name is Holtz method, so just choose E1. All right, and the series values, click on this button. Now start with the blank, even though there's nothing here, start with E2 and select E2 to E49. So E2 to E49, and hit this, and hit OK, and hit OK. And if you did this right, you should see, we'll add a legend, but see how this is the actual data, and the forecast gives us this, it keeps the upward trend, but it doesn't really know, it can't really predict these fluctuations. But you should see that the Holtz method upward trend forecast is this. Okay, so let's see if we need to do that again. Okay, so did that work? Do you want me to do that part again? All right, did everybody got this? All right. Okay, so all I want to do here is just add a legend so you can see what is what. So if you click on the chart, all right, so the next step is you would have got this red line, which is the forecast from Holtz trend. And so let's add a legend. If you click on the plus sign, and when you get the chart elements, just click on legend and hit OK. or don't hit anything, just click it. Maybe, actually, I don't, why did it put it right there? So let's move the legend down so it doesn't take up the whole space. Okay, so if you go to legend that you checked and go hit this arrow, and let's put the legend at the bottom. There we go. All right, so you can see that this is the actual sales data, the historical, and there's a clear upward trend, and the Holtz method captures or incorporates that upward trend, so the data in the future is expected to kind of go up, a little bit, just incorporating the trend. You can see this is the blue line is the sales, and the red line is the Holtz method forecast, which keeps the trend going. Okay, so we have another exercise to do, but we're about done with this one. Everybody good on this one? Everybody got everything for example 14.7? All right, so let's see. All right, so we finished example 14.7, so you can save that. All right, and that goes here by next Tuesday. So we did example 14.7. We still got to do example 14.8. All right, so for example 14.8, you can open up the soft drink sales Excel file like this one here. All right, so example 14.8, we're going to look at another type of exponential smoothing. This will be the final one, but this one's important too if you have a different type of pattern you see in your data. So for example 14.7, that was for Holtz method if you see a trend, and this video goes with that one. For the next one, we're going to use something called Winters's method, and this is if your data has seasonal behavior. So let me introduce this one, if I can find the description. All right, so this is going to be forecasting quarterly soft drink sales. So the data in the soft drink sales file represents quarterly sales in millions of dollars for a large soft drink company from quarter one of 92 to quarter one of 2007. And there's been an upward trend in sales during the period, and there's also been a fairly regular seasonal pattern, which is what we're trying to learn about here. So if you see in the picture, and we'll generate a graph, but sales in the warmer quarters, 2 and 3, go up, and then in the cooler quarters, 1 and 4, they go down. So how well can Winters' method track this upward trend and seasonal pattern? So this is the idea. not only do we have a trend, but we have, so see how this is for soft drink, like cold soft drink sales. Those sales go up in the warmer periods and down in the colder periods. So, like when it's 100 degrees out, people buy more soft drinks, but when it's 40 degrees out or whatever, then nobody wants a cold soda, all right? So you can see that clearly that during the hotter months, sales go up, and during the colder months, sales go down, and that trend continues, all right, throughout the sample. So we're going to incorporate the fact that we expect our future hotter month sales to be higher, and we expect our future colder month sales to be lower. And we're also going to keep this upward trend. So, okay, so see how all these things you see in your historical data, you want to try to incorporate those noticeable factors in your forecast if possible. Okay, so this Winters' method is going to incorporate the fact that you keep what happened in the seasonal patterns into your forecast. Okay. All right, here we go. Example 14.8. Let's forecast quarterly soft drink sales using the file. And first thing we'll do is make a time plot. Okay, so here we are. This is the soft drink sales one. So we want to select everything in the A and the B column, including the extra months we're trying to forecast. So select A1 to B70. All right, so select A1 all the way to B70. All right, and then let's go ahead and make a graph of that. So insert, and let's just, you want this line chart, you can choose that one. Line chart. All right, and see, you can clearly see that there's specific pieces of data you can incorporate in your forecast. There's the upward trend, but also in the summer months, sales go up. In the winter months, sales go down, and that's every year. You expect that to continue, right? So if during this whatever, like 15 years, this happened, then it's probably going to happen again, right? Or I mean, unless there's a pandemic going on, and who knows what's going to happen. But for now, let's assume that this is the seasonal pattern is going to continue. So let's click on the chart. Let's click on the plus sign, and let's remove the chart title and add axes titles. All right, this is just US dollars, and this is the respective quarter. Okay, and while we're here, let's just add the legend. So then when we put the forecast on, it'll automatically update that. So if you click on this and click on the plus sign and go down to legend, all right, and then hit the arrow after legend and choose bottom. Okay, there we go. Okay, so now when we put the forecast on here, it'll show up in the legend, and it'll be right here in next to sales. Okay, so we got all we've done so far is make a plot of the historical quarterly soft drink sales over time, and you can see the upward trend and the seasonal behavior. Okay, so let's go to step 2. Okay, let's do our simple exponential smoothing, and then we'll compare it and see how much better the Winters' method did. So we'll start with what we know and show how this other method does it better, because it's going to incorporate that seasonal behavior. So step 2, let's just do an exponential smoothing with alpha equals 0.9 in the spot on the spreadsheet. Okay, so we're going to use data analysis again. So click on Data tab and then Data Analysis. Then again, we're going to choose exponential smoothing. So you can click on exponential smoothing and hit OK. All right, the input range is the sales column. So click on the button and the input range is B1. B1 to B62. Hit that. And the damping factor, we want an alpha of 0.9 again. So that means that 1 minus alpha, the damping factor, is 0.1. Click on the labels box, and then the output range is the area in the C column that's set up for the output range, which is C2 to C63. Okay, so here are your exponential smoothing options. Input range is B1 to B62. Damping factor is 0.1. Labels box is checked. And output range is C2 to C63. And hit the OK button. All right, so we got our exponential smoothing process here in the C column, yeah? All right, so if we got that, let's again format the C column to look like currency. You could click on the C, so it selects the whole C column, and then Home tab, format cells, currency, and 2 decimals with the dollar sign is good. Okay. Okay, and then if you scroll down, this is the exponential smoothing, simple exponential smoothing forecast with the alpha 0.9, and you want to make it go down one more quarter. So click on C62, grab the bottom right corner and drag it down one, and then this should be your next quarter's forecast. So it should say in cell C63 equals 0.9 times B62 plus 0.1 times C62, which is alpha times the last observation plus 1 minus alpha times the last forecast. So check that your value here in C63 is 4,562 and 14 cents. Okay, everybody good? All right. Okay, so step 3. Step 3, let's calculate the absolute percentage error, and then we'll compare the MAP with the simple method to probably the better method, which is the Holtz. I mean the Winters is which captures the seasonal behavior which we're looking for. So let's first just get the APE, then the MAP for the simple method. Okay, so starting in D3, here's your formula, equals ABS equals ABS, double parenthesis B3 minus C3 divided by B3. So again, the actual sales minus the prediction divided by the actual. So ABS B3 minus C3 divided by B3. All right, and then let's grab the bottom right corner of D3 and drag it down to the rest of to get the rest of the APs. All right, so drag it down to D62. All right, and then let's calculate the MAP, which is just the mean, the average of the AP. So in cell D72 equals average D3 to D62. Enter. All right, so hopefully we got that there, the 10.32%. So the mean absolute percentage error for the simple exponential smoothing was about 10%. And here, again, we can't do the Winters method without an add-in package for Excel. So I just did it separately in that a separate software program. Okay, so this is the respective MAPE for the Holtz-Winters method. And this is the MAP for the simple exponential smoothing. So you can see that this one, because it captured the seasonal patterns, it was double as good. So this one was 10%, and this one was only about 5% off. So clearly this one captures the seasonal behavior a lot better. And we would choose the Winters method, which has a much lower mean absolute percentage error. All right, so step 4, we compare the MAPs, and which method has the lower MAP? It's clearly the Winters method. Okay, and then obviously we're going to use that for our forecast for the next 2 years, which we have. And the final step here is let's add that to the graph, the better one, which is the Winters method with the seasonal behavior. So let's graph it, let's add it to the graph, and we'll see when you see the forecast, it'll look a lot like what you saw in the historical data. All right, so we got them in a graph. Data up to quarter 1 in 2015, and let's add our forecast that we got here for the Winters method in the next 4 quarters. Okay, so go back up. Okay, so same thing we did last time. We're going to add column E, the forecast, to the current graph. So click on the graph that you made, right click it, choose select data, and over here you should see legend, entries, series, click on add. The series name, click on that button, is Holt Winters. It's the same thing as Winters. Sometimes it's Holt Winters, sometimes it's Winters, but this is the same thing. Choose that. And the series values, click on this button, is everything in the E column. All right, so you want to select E2 to E70. All right, and then hit this button, and then hit OK, and then hit OK, and if that worked, yeah. Okay, so if you're able to do that, here's the historical sales data, the blue line, and it should have put in the Holtz Winters forecast, which is the red line. So you can see that it keeps the same predictable behavior for the seasons. So in the summer months, in the hotter months, sales are higher, going to be higher, we think. And in the colder months, around December, February, whatever, sales are lower. All right, so it keeps going on this upward trend, and it keeps the seasonal pattern. So you should see that red line, which captures the seasonal behavior you saw historically, and applies that to the 2-year forecast. Okay, so even though we can't do some of these advanced forecasting methods in Excel, you see the value of them. If you have a trend or a seasonal pattern or both, you can use a more sophisticated method to get a better forecast. Okay, so did we get that? We're about done with this one. Everybody get the graph here with the forecast on it? Okay, so for this one, you can save it. Okay, so we're done with the two spreadsheets, example 14.7 and 14.8. Last week we kind of I had some practice questions we didn't get to, so it's only 9:30, so I wanted to go back to some of the practice questions that go with last week's exercises because I knew that today's exercise would be done quicker. So let's go. So we're done with example 14.7 and 14.8. You can put those into the discussion forum, those two spreadsheets, by next Tuesday or whenever you're done, if you're done now. All right, so 14.7 and 14.8, we're done with those two spreadsheets. Those go in here by next Tuesday. It looks like a bunch of you already put those in. And so what I want to do now is just just go over a few practice questions that we didn't have time to get to last week that I want to get to now. So if you go back to, I think we did. Well, there's two. I guess we didn't get to any of them. So let's start with, if you go on Blackboard to example 14.2, 14.3, and 14.4, let's just run through the practice questions solved real quick, because I know we didn't have time to get to those. I think it was last Tuesday. All right, so 14.2, 14.3, 14.4. Just click on or open the practice questions solved. All right, so these will be some maybe preparation for what might be on the final exam. We'll still have a review session and some practice exam questions, but let's look at these. So here we have, remember we did the exercise where we had the different months and the units produced and the total cost and the estimated total cost, okay? So here's our prediction given the units produced and how units produced affect total cost, okay? And then here's our trend line of that in the equation, okay? So part A, calculate total costs, estimated total cost for month 17 using the linear trend line parameters. We've done this a bunch of times, but here's the trend line, $22,071 plus 200 times X. All you do here is plug in X in month 17, which is 400. So if we expect to produce 400 units, what's the associated total cost given this equation? That's just total cost month 17, the intercept 22,071 plus 200 times X of 400, and that gives us a total cost of $102,071. All right, and then you can do the same. Calculate the total cost for month 18 using the linear trend line parameters. Use the same equation, but in month 18, you expect to produce 800 units, so put that in for your X. Okay, so we get month 18, 22,071 plus 200 times 800. That gives us a predicted total cost, month 18, of $182,071. Okay. All right, so those ones are not too bad. You kind of put in the X value to give you your projection on the trend line. Okay, but question 2, this one's a little bit different because we had the multiple X's. So remember we had different units, and this is the summary output of something similar we got in the exercise. So we did this with data analysis, and here's your summary output for this one that has multiple units. All right, so A, we estimated a multiple regression with total cost as the dependent variable, units A, units B, and unit C as the 3 independent. All right, so we got 3 X variables this time. And what's our multiple regression equation using the estimated coefficients? And then what's the interpretation of the R squared and the coefficients for A, B, and C? Okay, so remember, just getting the coefficients, we're able to write the equation, which is total cost equals the intercept, 17,480.08 plus the coefficient for units A, 15.80 times units A, plus the coefficient for units B, 19.10 times unit B, plus the coefficient for unit C, that we got here, 1463 times unit C. So that's our equation that you can just write with the coefficients. And remember, the R squared is the percent of explained variation in the dependent variable. All right, so if you get 0.93, that means that roughly 93% of the variation in total cost is explained by the regression equation. And then finally, you can interpret the specific coefficients, what those mean. So for units A, it's 15.80. That means that's the average cost to produce 1 unit of product A. So the cost to produce 1 unit A is about $15.80 on average. For unit B, coefficient is 19.12, so the cost to produce 1 unit B is about $19.12 on average. And then the cheapest one is unit C, that's the coefficient, 14.63, which means the cost to produce 1 unit C is about $14.63. All right, so those are the questions that you get that go along with the summary output for the one with multiple products. All right, and then finally, the next one, cost regression 3, we had the production at different plants, and we had to create the binary variables. So here's a summary output for that one. So we estimated a multiple regression equation with total cost as the dependent variable that units produced. And we had the different plants, plant 2 and plant 3, as the 3 independent variables. And remember from the exercise that we didn't have plant 1 specified, because when plant 2 and plant 3 are both 0, that's automatically plant 1. So plant 1 is the case when plant 2 and plant 3 are both 0. And what's our equation using the estimated coefficients? And then let's interpret the R squared and the coefficients. All right, so again, just use the coefficients where total cost is the intercept, 12,167, plus the effect of units produced, 204 times units produced, plus the effect of plant 2, 12,968 times plant 2, minus the coefficient for plant 3, it's negative 14,981 times plant 3. So that's how you just write out the equation in full form with the coefficients you get from the summary output. All right, adjusted R squared is 0.99, so that means that about 99% of the variation in total cost is explained here. And if you interpret these coefficients for units produced, that's the effect on total cost of changing units produced by 1 unit. So that means the average cost to produce 1 unit is about $204. And these ones are the binary variables. So this is the separate effect on total cost if you're producing at plant 2 compared to the emitted plant, which is plant 1. So 12,968 means that total cost is 12,968 higher at plant 2 on average compared to plant 1. And this one means it's lower at plant 3 compared to plant 1. So negative 14,981 means total cost is 14,981 lower at plant 3 compared to plant 1. So these are both the binary effect if we're producing at plant 2 or plant 3 in comparison to plant 1. Okay. All right, so those are the practice questions, and so we ran through those pretty quick, but let me know if you have any questions on those. And let's we still have plenty of time, so let's run through the other practice questions for Thursday's exercise, and we'll still finish pretty early, but I just want to get to the things we didn't get to last week. Okay, so we're done with this. Last thing we'll do today is go to Where are we going? 14.5 and 14.6 on Blackboard. So we did these ones on Thursday. The hardware sales with the moving average and the simple exponential smoothing. We didn't get to the practice questions. Let's run through those real quick, and this will be the last thing for today, and then we'll be all caught up. All right, so example 14.5 and 14.6, practice questions solved. Okay, so here's one on the, so I just, all I want you to know here is how to manually calculate the moving average process, which is pretty easy, but it's important to understand what we did in Excel. So here's the hardware sales. Here's the end of it up to week 104, and we're trying to use MA, a moving average of 2, and a moving average of 4. Okay. So what's the week 105 sales forecast using an MA2, which is a moving average of 2? So all you have to do to know how to do that is just take the average of the previous 2 observations. So that's the average of 102, week 103, and 104. So 1,903 plus 1,702 is the previous 2 forecasts. So just take the average of those 2, add them together, and divide by 2, and you get an MA2, 1,802 and 50 cents. What about if you use an MA4, a moving average of 4? All that means is you take the average of the last 4 observations. So this one, 2,361 plus 1,658 plus 1,903 plus 1,702. So those are the last 4 observed sales data. Add those together and divide by 4, and a MA4 would be this, 1,906. Okay, so all you have to do to calculate a moving average is just take the average of the last specified, so MA2, take the average of the last 2 observations, MA3, take the average of the last 3 observations, and so on. Okay, this one is for the exponential smoothing. So last concept here is we got sales data, the same sales data, and we tried an exponential smoothing with alpha equals 0.2 and an exponential smoothing with alpha equals 0.9. So how do you get the calculations for that? Use the simple equation, part C. What is the week 105 sale forecast using alpha equals 0.2? So remember the equation is just 0.2 times the last forecast. All right, alpha times the last observation, which is 1,702, plus 1 minus alpha, 0.8 times the last forecast for that series, which is 1,776.89. So it's alpha times this plus 1 minus alpha times this, which is 0.2 times 1,702 plus 0.8 times 1,776.89, which gives us our 105 forecast for an alpha equals 0.2 of 1,761 and 91 cents. All right, and then what about, so the same equation, but if your alpha changes, you got to change that accordingly. So what if the alpha is 0.9? So again, it's still alpha times the last forecast plus 1 minus alpha times the last, it's alpha times the last observation plus 1 minus alpha times the last forecast. So here we got alpha is 0.9. The last observation is still 1,702. And that means that if alpha is 0.9, then 1 minus alpha has to be 0.1. And the last forecast from alpha equals 0.1 is this one. 0.9. So 1,884.47. So here's the last observation. Here's the last forecast for alpha equals 0.9. And those are the two pieces of data you need to calculate the exponential smoothing forecast for the next month. So it's 0.9 times 1,702 plus 0.1 times 1,884.47. Okay, so I just want you to know how to use the simple exponential smoothing formula and be able to calculate different step ahead forecasts by just changing the alpha. Okay, so this one comes out to 1,720 and 25 cents. All right, and then finally part E, what does the alpha do specifically in an exponential smoothing model? Remember that changes the weight you put to the previous observation. So when the researcher increases alpha, that means by definition that more weight is given to the last observation. And alpha ranges from 0 to 1, where 0 would mean that there's nothing, no weights given to the last observation. And the other extreme is alpha equals 1, where 100% of the weight is given and the forecast is just simply the last observation. Okay, so the point here for simple exponential smoothing is that when you increase alpha, you're giving more weight to the last observation, and when you decrease it, then you're giving less weight to it. All right, so those go through some practice questions that are associated with last week's exercises, Tuesday and Thursday. So make sure you understand those practice questions because there'll probably be something similar on the upcoming final. And if you have questions or don't understand any of those concepts, then please let me know. But yeah, so we are done with this. All right, so the exercises we did today, example 14.7 and 14.8, go in here by next Tuesday. I think we'll finish a little bit early today. That's what I wanted to cover, those two exercises, and then finish up the practice questions. So I think we're all caught up. But yeah, I think that's it for today. And everyone, thanks for joining, and stay safe. Have a good rest of your week, and I'll see you Thursday morning, same time.